So hello everyone, in this video we are going to see another problem based on recursion. Like it is not based on recursion, we will solve it using recursion to understand recursion better. So the problem is rod cutting problem and we will solve it using recursion. So basically, first of all, I will be explaining it what the problem is, and also I will be attaching the problem statement and the code link in the description box. You can check the problem statement and read the problem statement thoroughly and get a much better understanding of what is problem statement, and then you can try solving it on your own also. So first of all, what we have to do in this problem is, so for example, in the input we are given n is equals to 5, and then we are given three variables: a equals to 2, b equals to 1, and c equals to 5. And then the output that we have got is 5. So in this problem, what happens is, so the first n that you can see, is the size of the rod, you can say. So let's suppose this is a rod. So the size of this rod is n equals to 5. So okay, 5 unit is the size of this rod. Now what are these three variables, a, b and c? These three are the number of like the length of the cuts that you can make on this rod. So you have to make such cuts on this rod that the pieces that you return should be maximum. For example, let's see what are the cuts that you can make on this rod. So the cuts that you can make on this rod by using two are, uh, one cut you can make is of size 2, other you can make is of size 2, and the remaining will be of size 1. So this can be a given, like this can be an approach of cutting this rod. So likewise there are many ways. Okay, again let's see one more example. So if we take this C, then only one cut, and we will not make any cut, just simply we will have the entire rod as our answer. Again, if we take this one, so there can be a case where we will make 5 cuts on this rod. Okay, so 1, 2, 3, 4, and 5. So this will result into the maximum number of pieces of the rod. So like in this case, we will get 5 pieces of the rod. So this is the answer that we have to get. So this is the output that we are getting. So we have to cut the rod and we have to compare all the number of pieces that we have got. Like in this case, first of all, we have got 3 pieces, right? So again, we have got like different kind of pieces we will get when we will make different cuts. Okay, so we have to compare all of them, and finally we have to give the uh, answer in which we have got the maximum number of pieces. So this problem might sound you a bit complicated, but let's see how we can solve this. So we can solve this using recursion. Let's see how. So first of all, let's see the approach how we can solve this. Basically, what we will do is, we will try to cut this rod for each and every partition. Like let's see, we will start from 5. Now there are 3 cuts that we can make on this rod. Okay, 2, 1 and 5. Now if we will make a cut of size 2, the remaining length that we have will be 3, and in this case we will have 4, and in this case we will have 0. So again, on the remaining portion that we have got in this case is 3. When we make cut on this, we can make 3 cuts. If we will make a cut of size 2, then in that case we will get the remaining length as 1. If of one size, then we will get the remaining length as 2, and in this case we cannot make any cut, so we will simply write this negative, because when we will make the cuts we will get negative. Okay, now again for one size, so there is 2, 1 and 5. For both of these cases we will get negative, and for this we will get 0. Now for 2, we have 2, 1 and 5. So in this case we will get 0, in this case we will get 1, and in this case we will get negative. Okay, and then for 1, when we will check, again we will get this same situation where we will get negative, 0 and negative. Okay, so now let's check for this n equals to 4. For n equals to 4, if we will check, we will have 2, 1, 5, and again for the 2, we will get this same thing, this one, this same tree we will get over here in 2's case, and in 1 it will give us 3, and again it will be called, and in 5 it will give negative. Okay, so now when it will be called on 3, we have 2 1 5, so we will get 1 2 and negative. So you can see that in this way we will be checking until we will get the size 0. So we have to find the maximum length of the tree. So as you can see that if we will check this case like this tree, then 1 is the size until here it is 2, until here it is 3. So in this tree, if we have checked, we have got the size as 3. Now let's go this way. If we will go this way, let's just a minute. If we will go this way, this and this and this, and then in this case we will get 4 as the length. Now there is one more way where we can check, that is from here 1 2 3, and if we will move for, sorry, not this one, on the side of 1, and if we will move further, 2 will have further more 3 cuts, which of 2 1 and 5. So this will give 0, this will give 1, and this will give negative, and again 1 will have 3 more cuts of 2 1 and 5. So this will be 0 and they both will be negative. So now if we will traverse through this path, so you can see that 1 2 3 4 and 5. So in this case we have got the length of the rod as 5, and in this case we will only get simply 1 because we have not made any cut and just one piece only. So in this case we have got the maximum number of pieces of the rod. So this is the approach that we are going to use to solve this problem, and let's now write the function for this, so in order to get a better understanding. So basically what we will do is we will write the function for cutting rod cut, and this function will take 3 parameters, which is int n, a, b, c, 4 parameters. Now what it will do is basically it will take a variable result and will store the maximum of, let me write it first and then we'll explain, maximum of a, b, c, a, b, c, a, b and c. Now once this is done, so what we are doing in this case is, first of all we are calling the rod cut function for the inputs n, a, b and c. Now as you can see that we have called the rod cut function on 5 where n is equals to 5 and a, b, c is 2 1 and 5. Now again in the next case what we are doing, we are making 3 calls on different n values. The first n value is n minus a because our a is 2, b is 1 and c is 5. So what we are doing is we are again calling the same function on different n value. And what is the n value in this case? It is 5 minus 2, which is 5 minus a, or you can say n minus a. So we are calling the function again on n minus a value, and in this case also the a, b, c value will remain same only. Similarly we are calling the n function rod cut again on this n minus a value, which is 4 in this case, and again a, b and c will be same, and similarly we are calling the rod cut function again for n minus a value, which is in this case we will get the n minus a as 0. So that is what we have written here. So we will call 3 times rod cut function on different n values. Initially in the first case our n value will be n minus a, in second case the n value will be n minus b, and in the third case the n value will be n minus c. But the a, b and c value will remain same in all the 3 cases as we have just seen. Now out of all these 3 calls we have to return that answer which gives us the maximum value. Okay, so the maximum value, as you can see in both of these in all of these three cases will be returned by this number. Why we are taking the maximum count? Because as you can see that we are considering the minimum cut value, minimum length cut value, because in this case as you can see that the minimum length cut value will be 1, so the remaining length will be the maximum. Okay, so we are taking that into consideration. And now we also have to check the edge cases, because in many cases we will get negative values. So what we have to do when we get a negative value? So for that, what we have to do is we will simply write if the result value that we got is equals to -1, then in that case we simply return -1. Okay, so and the what will be the base case is whenever our length of the n reaches 0, then in that case we have to stop and simply return 0. Otherwise, if our n value goes less than 0, then in that case also we have to return -1. So let me explain these two base cases first. So suppose in this case our n value has reaches 0. So in this case we will simply return 0 from here. And there is other case where we have got n value is negative. In this case you can see. So in this case we will simply return -1. -1 in this case. So these two are the base cases that we have covered. Now the result value, if the result is -1, then we have to return -1 from that. So there can be a case where in all of the three cuts that we make, we will get the negative values only. So in that case, suppose if for example, if we have the n value as 5 and the cut value as 6, 8 and 9. So in all of these three cases, we will get negative values only. So in that case, the maximum value will be also a negative value. So in that case, if the result value is -1 or negative -1, which means negative, so in that case, you can return -1. Now finally, what we will return at the end of the code, we will return simply the result value that we have plus 1. Okay, so in this example, if we will get -1 is the value, then it will be -1 plus 1, so it will return 0. So as you can see, there can be no cuts made on this given input, because all of the given sizes are greater than the given input. Okay, so in this case we will at the end of the code we will simply write this thing, that is return result plus 1. So it will give us the size 1 plus to the result that we have got, because as you can see we have traversed this path. Okay, so this will return 1, this will return 1 plus 1 2, again this will return 3, and this will return 4. Now at the end, similarly we have to give an addition of 1 for this. So that is why we have written result plus 1 in this case. So now let's see the code for this. So this is the code for rod cutting problem. So in this code we have written exactly the same conditions that we have just seen in the example. This condition will calculate the result value, that is the maximum of all the three values, and this is the base condition. If at the end, if the n value becomes 0, then we have to return 0 in that case. If the n value becomes negative or -1, then in that case we have to return -1. And finally, there is one more condition that we have to check, that if all the three sizes or all the three values of a, b and c are greater than n value, then in that case also we will get the result value as -1, and in that case we have to return the -1. And finally, at the end we have to return result plus 1. Whatever the result value is, we have to simply add 1 to that, and we have to return. So this was the input that we have in the example, that is 5 is the n value, and a value is 2, b value is 1, c value is 5. So for this, as we have seen, we should get the output as 5, because the number of pieces after cutting we will get as 5. So as you can see, the output that we have got is 5. So the time complexity of this problem will be big O of 3 raised to n, because in this case, as we have discussed, we have created a tree, and the tree has 3 children nodes. So in this way, we can calculate the time complexity for this problem, which will be big O of 3 raised to n. As in the input we have 3 cuts, 3 sizes of cut, that is a, b and c. So that is why we can say 3 raised to n. If we have 4 A, B, C, D, then we can simply write 4 raised to n. So thank you.